In this first example, we are going to take our definition of subset that we just defined, and we are going to use that to determine whether set A is a subset of set B. For some of these problems, we might include some extra information that isn't really necessarily part of the question, but since we're exploring the idea of subsets and kind of tying into some other things that we've looked at, we're going to kind of add in some additional information as well as just the answer to this question. Right, so for example A, set A includes marigold, pansy, and tulip. Set B includes marigold, pansy, begonia, and tulip. So how we're going to determine this, if we look at this little line up here that I have a little green star next to, that's what we're going to use to determine whether or not A is a subset of B. If all of the elements of set A are also elements of set B, then A is a subset of B. All right, so we look at the elements of A. Marigold, well, that's also in B. Pansy, well, that's also in B. And tulip, that's also in B. So since all of these elements are also elements of B, then we can say that A is a subset of B. Right. So for example B, A is numbers 2, 3, 4, 5. Set B are the numbers 2 and 3. So if we look at this, again, we're going to make sure that every element of A is an element of B. 2 is in A, which is also in B. 3 is in A, which is also an element of B. 4 is an element of A, but notice that 4 is not listed here. Right? In order to be a subset, everything in this set has to be in this one. That is not the case. So we're going to say that A is not a subset of B. However, if we were to reverse this, right, everything in B, our elements, the numbers 2 and 3, are in A. So we could reverse this and say that B is a subset of A. Right? So as we're working through these, depending on which letter comes first, right, that does make a difference. So A is not a subset of B because everything is A is not in B. But B is actually a subset of A because everything in B, those two elements, are also elements of set A. All right, for example C, set A includes vanilla, chocolate, and Rocky Road. Set B includes chocolate, vanilla, and Rocky Road. So we're going to make sure every element in set A is also in set B. So we have vanilla in set A, also in B. Chocolate in set A, also in B. Rocky Road in set A, also in B. So in this case, we're going to say that A is a subset of B. Right, now if we look at these, notice that these sets are the same. Right? Same different 3 elements, just in different orders for each of these. So we're also going to say B is also a subset of A. Right? Since all of these, if we went the other way, are also inside A. We could also say that A equals B, right? Because our sets are exactly the same. So thinking back to the last section, we're using our definition of equal. We have the exact same elements in both sets. And we could even go one step further. We could say that the number of elements in set A, our cardinality of set A, is equal to the number of elements in set B, our cardinality of set B. Remember, if our number of elements, our cardinality, is equal, then we have equivalent sets. Maybe we should use the words, if our cardinalities are the same, then we have equivalent sets. So in this case, A is a subset of B. B is also a subset of A. They are equal and they are also equivalent. Right, we're going to finish off example D. Set A is the set of all X such that X is a yellow fruit. Set B is the set of all X such that X is a red fruit. In this case, you can't be both a yellow fruit and red fruit at the same time. So we're going to say that A is not a subset of B. So again, as we're thinking about subsets, in order to be a subset, every element of set A also needs to be an element of set B if we are determining if A is a subset of B. Again, if we reverse or change the order of our sets, then we need to make sure that every element of our first set is also an element of that second set using our notation.